Archaeologists are baffled by what Puma Punku was, how it looked, and what the purpose of this enormous structure would have been.
At an altitude of 12,800 feet on a windswept plain overlooking Lake Titicaca in Bolivia lies a collection of enormous stone blocks that has puzzled researchers for more than a century. Nothing about this site seems straightforward. For over 120 years, archaeologists have surveyed the ruins, studied every carved surface, and left with more mysteries than answers. The stones are carved from andesite and red sandstone, two of the toughest rocks found in the region. Their edges are astonishingly sharp, their faces remarkably smooth, and their internal cuts so intricate that no one has been able to determine exactly how the original structure was assembled. Despite decades of investigation, modern archaeological teams and even advanced 3D reconstruction software have failed to recreate the monument from the surviving blocks. This extraordinary place is known as Puma Punku. The civilization traditionally credited with its construction is the Tiwanaku culture, but whether they actually built it remains one of archaeology's greatest unanswered questions. Dating somewhere between the 5th and 10th centuries AD, Puma Punku continues to challenge everything historians thought they knew about ancient engineering in South America. For decades, the accepted explanation has remained largely unchanged. According to mainstream archaeology, the Tiwanaku were an advanced pre-Columbian civilization equipped with stone tools, copper implements, abrasive sand, and an immense workforce. Researchers believe they quarried these massive stones, transported them using ropes and ramps, and carefully shaped them by hand until each block fitted into place. Simple enough. But before we reveal why that explanation may not tell the whole story, make sure to subscribe to the channel and turn on notifications, because the evidence you're about to see has left even experts questioning everything they thought they knew about Puma Punku. Except there's one major problem. No one has ever been able to successfully demonstrate that this method could actually produce the incredible precision seen at Puma Punku. Then, in late 2024, the debate took an unexpected turn. A European geoarchaeology team introduced technology never before used at the site, a structured light 3D scanner capable of detecting surface variations as small as 0.01 millimeters. To put that into perspective, that's a level of precision exceeding the manufacturing tolerance used for many modern aircraft components. Researchers scanned the famous H-shaped blocks, examined their internal grooves, and mapped the perfectly cut corner joints that have long puzzled experts. The results reignited a debate that archaeology has struggled with for decades. Either the Tiwanaku possessed construction techniques far more advanced than previously believed, or Puma Punku was built by an even earlier civilization before the Tiwanaku ever arrived. Neither possibility fits comfortably within the traditional history of pre-Columbian South America. To understand why this discovery matters, we first need to understand who the Tiwanaku really were. The Tiwanaku civilization emerged around 300 AD along the southern shores of Lake Titicaca, the world's highest navigable lake. Between roughly 500 and 900 AD, their influence stretched across present-day Bolivia and into parts of Peru, Chile, and Argentina. This was not a small tribal society. It was a powerful, organized civilization with advanced farming techniques, extensive trade routes, and impressive monumental architecture. Its capital city, also called Tiwanaku, may have supported a population of 20,000 to 40,000 people, making it one of the largest urban centers in the ancient Andes. The civilization engineered raised agricultural fields that allowed crops to thrive at extreme elevations, developed sophisticated irrigation systems, produced distinctive ceramics, traded across the region, and carved towering stone monuments, including the famous Bennett monolith, which stands more than 24 feet tall. No one disputes the achievements of the Tiwanaku. The real mystery is something much more specific. Did they truly build Puma Punku? Because unlike the rest of the Tiwanaku complex, Puma Punku appears to belong to a completely different level of engineering. Just a short distance away, the main ceremonial center features remarkable but understandable architecture, stone walls, temples, terraces, and carefully planned structures that fit within what historians expect from an advanced, ancient civilization. Puma Punku, however, seems to follow an entirely different set of rules. Puma Punku simply doesn't fit the pattern. The stonework found here rivals only a handful of ancient sites, such as the Serapeum of Saqqara in Egypt and the finest Inca masonry at Cusco and Ollantaytambo. The blocks are astonishingly precise. Their surfaces are remarkably flat, their angles match perfectly across multiple stones, and their grooves and interlocking joints are so intricate that no one has successfully recreated the original construction method. Then there's the material itself. Most of the blocks are carved from andesite and red sandstone. Andesite is an extremely hard volcanic rock, ranking 6 to 7 on the Mohs hardness scale. Copper, by comparison, measures only about 3. In simple terms, copper tools would wear out long before they could efficiently shape the stone. If these blocks had been carved using traditional hand tools, researchers would expect to see rough chisel marks and uneven surfaces. Instead, they found something entirely different. The faces of the stones are unusually smooth. The corners are razor sharp. The grooves are so consistent, they almost appear machine-produced rather than hand-carved. That is the mystery that has challenged archaeologists for generations. The craftsmanship appears to surpass the tools that were supposedly available. The precision seems greater than the technology historians believe existed. And no explanation has completely resolved that contradiction. One of the first people to investigate the site in detail was Arthur Posnansky, an Austrian-Bolivian engineer who devoted more than 50 years to studying Tiwanaku and Puma Punku. He carefully mapped the ruins, measured countless stone blocks, and proposed several controversial ideas about their origin. His boldest claim involved astronomy. Posnansky argued that certain structures aligned with solstices, equinoxes, and other celestial events. Using Earth's changing axial position, he estimated that the original complex may have been built around 15,000 BC. That conclusion has been overwhelmingly rejected by modern archaeology. Radiocarbon dating consistently places the site between 300 and 900 AD, during the height of the Tiwanaku civilization, and Posnansky's astronomical dating is widely regarded as unreliable. However, one part of his research has continued to attract attention: his measurements of the stonework. He documented the extraordinary precision, the complex joints, and the remarkable symmetry, arguing that the craftsmanship exceeded what Stone Age or Bronze Age technology should have been capable of achieving. Decades later, engineers and independent researchers using modern measuring equipment reached many of the same observations. Again and again, the results pointed to incredibly flat surfaces, perfectly repeated angles, and internal geometries manufactured with astonishing consistency. These are the kinds of tolerances normally associated with precision engineering, not simple hand tools and copper chisels. Mainstream archaeologists suggest that the Tiwanaku shaped the hard andesite using diorite hammerstones, another extremely hard rock with a hardness similar to granite. But whether that method alone can account for Puma Punku's extraordinary level of precision remains one of archaeology's most hotly debated questions. Mainstream archaeologists argue that the Tiwanaku shaped Puma Punku's stone using diorite hammerstones, repeatedly striking the hard andesite until the desired form emerged. This method is well documented and was used in places such as the ancient granite quarries of Aswan, Egypt. The unfinished obelisk there still displays the unmistakable signs of this technique: rough surfaces, uneven tool marks, and evidence of slow, labor-intensive stone removal. The theory itself is reasonable. The problem is that it doesn't fully match what researchers see at Puma Punku. Hammering with diorite is effective for removing large amounts of stone, but it doesn't naturally produce the exceptionally smooth, flat surfaces found throughout the site. To achieve that level of precision, the builders would also have needed grinding, polishing, and abrasive finishing techniques. Ancient civilizations certainly knew how to polish stone. The Egyptians, for example, created mirror-like finishes on granite using sand and years of painstaking work. But those efforts were typically reserved for royal monuments and sacred structures because they demanded enormous amounts of time and labor. At Puma Punku, however, this extraordinary precision isn't limited to just a few special pieces. It appears across hundreds of stone blocks. The site's famous H-shaped blocks all display remarkably consistent dimensions, sharp edges, and intricate grooves. Rather than looking individually handcrafted, many appear almost identical, as though they were produced according to the same design template. That's where the mystery deepens. Traditional hand finishing usually leaves subtle differences. No two craftsmen carve stone in exactly the same way. Slight variations in angles, depth, and surface texture are normally expected. At Puma Punku, those differences are surprisingly difficult to find. Instead, researchers see a level of standardization that resembles controlled manufacturing rather than individual craftsmanship. How this consistency was achieved remains unknown. Among all the discoveries at the site, the H-shaped blocks continue to attract the greatest attention. Viewed from above, each resembles the letter H carved from a single piece of stone, with a complex arrangement of grooves, recesses, and projecting sections. They were clearly designed to interlock, allowing one block to fit securely into another, without the need for mortar. The engineering concept is obvious. The puzzle is that many of the blocks don't actually fit together. Some match perfectly, while others differ slightly in size and shape. It's almost as if they were produced in different batches, built to different specifications, or belong to sections of a structure that no longer exists. Despite more than 120 years of study, no one has successfully reconstructed Puma Punku's original appearance. Researchers have tried computer simulations, physical reconstructions, and detailed engineering models using every surviving block available. None have produced a universally accepted solution. This leaves several possibilities. Perhaps the original monument had an architectural design unlike anything else in the ancient world. Perhaps many of its stones have simply disappeared over time. Or perhaps the structure was never completed at all. That final possibility is rarely discussed, but it raises intriguing questions. If the builders quarried, shaped, and transported the blocks before abandoning the project, it would explain why so many pieces remain scattered without an obvious arrangement. It could also account for the slight differences between blocks, making the site resemble an unfinished workshop more than the ruins of a completed monument. But that leads to an even bigger mystery. Why would such an enormous project be abandoned? The Tiwanaku civilization didn't suddenly vanish. It gradually declined over several centuries before eventually being absorbed into the expanding Inca Empire. There is no clear evidence of a catastrophic event that would explain why construction abruptly stopped, unless the project wasn't started by the Tiwanaku at all. Some researchers have suggested a far more controversial possibility, that the Tiwanaku arrived to find many of these massive stone blocks already cut and scattered across the site, inheriting the remains of an even older civilization. This idea falls well outside mainstream archaeology because it implies the existence of an unknown culture predating the accepted timeline. Even so, supporters argue that it offers one possible explanation for why Puma Punku continues to resist every attempt at reconstruction. The mystery surrounding Puma Punku goes far beyond its stone blocks. Many researchers point out that the precision of the site appears to exceed what the Tiwanaku civilization is believed to have been capable of achieving. The unfinished appearance of the ruins, combined with the simpler construction found elsewhere at nearby Tiwanaku, has led some visitors to believe that two very different levels of craftsmanship exist side by side, one remarkable, the other comparatively ordinary. Something doesn't seem to fit, and for more than a century, the usual explanations haven't completely solved the puzzle. The site's location only makes the mystery even greater. Puma Punku sits at an altitude of 12,800 feet, where the air contains roughly 40% less oxygen than at sea level. At that height, even routine physical work becomes exhausting. Modern workers tire quickly, require frequent breaks, and accomplish far less than they would at lower elevations. Now imagine moving stone blocks, weighing over 100 tons under those conditions. The challenge seems almost unimaginable. The nearest source of the site's massive andesite blocks lies around 10 miles away, across rugged mountain terrain filled with slopes and ravines. The red sandstone traveled even farther, with some estimates placing its quarry more than 50 miles from the construction site. How were such enormous stones transported across the Andes without modern machinery? The traditional explanation is simple: manpower. Archaeologists suggest that thousands of workers used ropes, wooden rollers, ramps, and coordinated effort to haul the stones into place. It's certainly possible. History has shown that organized labor can achieve extraordinary feats. Egypt's pyramids stand as proof of what determined workers can accomplish. But there are important differences. Egypt had vast resources, river transport, and a much larger population. The Tiwanaku civilization was smaller, operated in a harsher environment, and still somehow produced stonework that many believe exceeds the limits of its available technology. For many researchers, the altitude doesn't just complicate the construction, it makes the entire project far more difficult to explain. Either the Tiwanaku possessed engineering techniques that remain poorly understood, or Puma Punku has a far more complicated history than currently accepted. In 2024, researchers examined the site using technology far more advanced than anything previously available. Earlier surveys relied on rulers, calipers, and straight edges, accurate to about a millimeter. This new study was very different. Scientists used a structured light 3D scanner, a system that projects patterns of light onto an object and measures tiny distortions to create an extremely detailed digital model. The scanner could detect variations as small as 0.01 millimeters, roughly 1/10 the thickness of a human hair. It's the same type of equipment used in aerospace and automotive engineering, where components must meet extremely strict manufacturing tolerances. Researchers scanned several H-shaped blocks, along with large platform stones. The results confirmed what many had long suspected. Some surfaces remained flat, to within 0.05 millimeters across spans, measuring several feet. That's not simply smooth, it's engineering-level precision. Even more remarkable were the internal corners of the H-shaped blocks. Many deviated from a perfect 90-degree angle by less than 0.1 degrees, the kind of accuracy modern machinists expect when manufacturing parts that must fit together with almost no room for error. Those measurements have once again reignited one of archaeology's biggest questions. How was such extraordinary precision achieved thousands of years ago? The 2024 scans revealed something astonishing. The grooves on Puma Punku's stone blocks maintained a consistent depth of less than 0.1 millimeters. Their walls were perfectly parallel and their surfaces incredibly flat. Precision more commonly associated with modern machine tools than ancient hand carving. Researchers avoided making extraordinary claims, but the data raised a difficult question. Either the Tiwanaku possessed engineering techniques far beyond what historians believe, or the accepted story of Puma Punku is incomplete. The mystery grows even deeper when we look at America's history. Recent discoveries at Monteverde in Chile and White Sands in New Mexico suggest humans reached the Americas thousands of years earlier than once believed. If people arrived much earlier, could advanced cultures have existed long before the Tiwanaku? Some researchers even suggest Puma Punku may have been built on the foundations of an older civilization, with the Tiwanaku later inheriting or expanding the site. There's no conclusive proof for this idea, but it could explain the extraordinary precision, the unfinished appearance, and why Puma Punku seems so different from nearby Tiwanaku structures. Today, Puma Punku is a UNESCO World Heritage Site, yet despite more than a century of research, one question remains unanswered. Who really built this extraordinary monument? And how did they achieve such incredible precision? Over the centuries, Puma Punku has suffered extensive damage. Stones were removed by Spanish colonists for construction, local communities reused blocks, and earthquakes scattered much of the original structure. What remains today is only a fraction of what once stood, making it nearly impossible to reconstruct the monument as it originally appeared. Yet even these surviving fragments are extraordinary. The remaining blocks display a level of precision that continues to challenge conventional explanations. Mainstream archaeologists credit skilled craftsmanship, simple tools, and years of patient labor. Others argue the measurements tell a different story. Surfaces that are exceptionally flat, angles of remarkable accuracy, and a consistency rarely seen in hand-carved stone. The debate continues because the evidence hasn't changed. Throughout history, archaeology has repeatedly underestimated ancient civilizations. Discoveries like the vast Maya cities revealed by LiDAR, the incredible precision of Egyptian stonework, and the sophisticated Antikythera mechanism have all forced historians to rethink what ancient people were capable of achieving. Perhaps Puma Punku is another example, not proof of aliens or mythical lost worlds, but evidence that ancient engineers possessed knowledge and techniques we still don't fully understand. Whoever built Puma Punku carved stone with astonishing precision, high in the Andes, then disappeared, leaving behind no written records, no instructions, and no clear explanation. Even the Inca, centuries later, believed the site had been built by the gods. Today, advanced 3D scans can measure every angle and every surface with incredible accuracy. But measuring something isn't the same as understanding it. We know how precise the stones are. We still don't know how they were made. More than 120 years after archaeologists first began studying Puma Punku, its greatest mysteries remain unanswered. Who really built it? How did they achieve such incredible precision? And what knowledge has been lost to history?